Good evening, my 11th standard warriors. Welcome to the lecture 6 of problem solving session of Advanced on Work Power Energy. This is Shreyas here, your physics master teacher, leading the JEE Physics division at Vedantu, going live from Bangalore. Hello everyone, those of you who do not know me, well, I have been training kids for a very long time, and under my guidance, many of my students have not just got into IITs but also secured top 2-digit rank in JEE and like examinations. So thank you for being here. Welcome to Enthuse. Enthuse is your special channel, exclusive JEE English medium channel. So all those students who want to prepare for competitive examinations are all welcome here. Hello Ishpreet Selva, happy birthday Zayed. Hello Harita, hello Roshni. Welcome aboard. Hello Jai Prakash. How is everyone? How is it? And are you guys now prepared for the next level of questions? Because today we're going to have some really killer questions, guys. So are you guys ready? Let me know by putting up a fire emoji in the chat box so that I know you guys are full of energy, full of josh, and let that josh remain high throughout the session. And also it's a good time that we congratulate all our passing out students who have made Vedantu and our teachers and our entire team really proud, and we are really thrilled to announce this, that so many of our students, your seniors, have done exceptionally well in boards, in CETs and JEE and NEET. The All India rank topper was the topper from Vedantu was All India rank 35. That's phenomenal, and you guys should make sure that you break those records next year. Hello Molesh, hello Saja, thank you for all the fire. Hello YouTube Hari, hello Chandana Srinivas, hello Sai Pujit, hello Avinish. I'm very good Ishpreet. Hello, good evening Swarlina. I'm very good Hari. Thank you guys for all the love and all the hearts. So guys, if you have not yet checked out our pro subscription courses, please check it out, because not only will you get live classes and the recorded lectures of those live ones, plus you will get your test, your assignments, your regular material, doubt solving. And if you want doubt solving after the class, then you go for the classic version, and if you want personal mentor, you can go for the plus version. The batches have just started on Monday. You can still join it. Do check out the link which is there in the description box. Plus you will get my micro course for problem solving sessions for 12th standard. Today's session is open for all 12th as 11th and 12th, as well as even the passing out students. So please do join in and get your friends in case they have forgotten to join today's session and that they are a regular warrior out here. Hello Roshan Kumar, is there a micro batch of mine? Yes, Rohan Kumar. In fact, I have lots of batches for 11th standard kids. One is derivation course, one is HC Verma course, one is Irodo course. Then there is this numerical problem solving course. All these micro courses of mine are available for free once you're a part of the subscription, and you can join it if you're already a pro member. Okay, so Sai Pujit, so this is our mock test series for JEE Advanced. You have already become a hero by learning the concepts for mains. We have already revised so many times all the concepts for mains. So now it's all about solving problems and scaling your level and knowing those different techniques on how to attempt those new variety of questions which might occur in your JEE Advanced examination. Yep. So let's begin. Mohammed, it's difficult, but it is not impossible. But yes, it is difficult for sure. Yep, it's very difficult. You need guidance, you need that support for cracking JEE Advanced. It's little bit difficult unless you're a true genius. Okay, so let's do this question coming up on your screen. There is a particle which moves along the loop A, B, C, D, A, while a conservative force acts on it. Remember the definition of conservative force. That will help you over here. Work done in a closed path is 0. Work done is independent of the path taken. That's what it is. Hi Shalindra, good evening. Hello Vaishal. And those of you who have forgotten to smash the subscribe button, and if you are new to the channel, please hit the subscribe button. And also, if you have hit the subscribe button, you know what to do. Your small guru Dakshina, go smash that like button out there in case you have forgotten it. Now the work done from A to B is minus 50. Okay, let's just write all these things down so that we are clear about it. So work done from A to B is minus 50. Work done from B to C is 25 joules. And work done from C to D is nothing but 60 joules. Okay, D to A is not given. I think it's not even necessary. Assume that the potential energy of the particle is 0 at A. Alright, so what you have to assume is the potential energy at point A is 0. So this is basically your reference. The question is, what is the potential energy at B and D? So the question is, what is the potential energy at point B and at point D? Alright, now the concept that we'll use over here is the formula for change in the potential energy. Because work done is given and potential energy is asked, reference is given, change in the potential energy is negative of the work done by the conservative force. Recollect this formula. The formula was the work done by the conservative force, the negative of that is delta U, which is the change in the potential energy because of the work done by the conservative force. I hope you recollect. This formula. Thank you, Vaishal. Thank you so much. Hello, Srasti, Kushawa. Welcome aboard, guys. Join in. This is the first question. Welcome all the 11th, 12th and the passing out students. Now, from point A to point B, here is what I'll write. Okay, so from point A to point B, what can I write? I can say minus work done from A to B is change in potential energy. That means final minus initial potential energy. What is the work done from A to B? The work done from A to B is nothing but minus 50 joules. This is UB. UB I do not know. UA is nothing but 0. It was given. Therefore, UB is nothing but 50 joules. So I have found out the first answer using this formula. The work done by the conservative force, the negative of that is the change in the potential energy between those 2 points. So UB was final, UA was initial, UA was given. It is 0. That's all. Yep. Indrani, yes, bacha. Yep, Mohammed, there are lots of classes for JEE Advanced on this channel. You can see all the mock test series, all the JEE Advanced classes have been conducted regularly on this channel. You can just go ahead and check out the past videos, Mohammed. You will find it over there. Okay, now for the next part, do the same thing but with different alphabets. So the question is to find the potential at point D, right? B and D. So do it for A, B, C, D path. So the work done for the path A, B, C, D, the negative of it, will be the change in the potential energy. So potential energy at D minus potential energy at A. What is the work done in this A, B, C, D path? Okay, well that's simple. That's minus 50. Okay, that's minus 50 plus this 25 plus 60. So plus 25 plus 60. This will be equal to UD minus UA is nothing but 0. Therefore, UD will be equal to 25 plus 60, that's 85. 85 minus 50, that's 35. So minus of 35. So minus 35 joules. That is the final answer. Guys, got it? Very good. No, Sai Pujit, it's minus 35. Be careful. Hello, Harshita. Hello, Vaishnavi. Welcome aboard. Oh, thank you, Suryan. Thank you, Suryan, so much. Yes, Roshni, minus 35 joules is the final answer. Excellent, guys. If you guys have got this answer, proud of you. Thank you so much for all your love and all your lovely comments. It really makes my day because we put in a lot of hard work, and when you guys love it and when you guys enjoy my classes and when you guys promote it and when you guys get in your friends, trust me, that's the best feeling that we get, and that's all what we want. We want you guys to improve. So that's the answer for the first question. Moving on to the next question coming up on your screen. Okay, so a block of mass 2 kg is connected to an ideal spring. Okay, a block of mass is connected to an ideal spring over here. It is placed on a smooth, that means there is no friction, and the spring is pulled to move the block at some rate, I think, and at some instant the end A has a speed of 6 meters per second and 3 meters per second is the speed of this point. So the end A has a speed of 6 and the speed of the block is nothing but 3 meters per second. So let us just write down all these informations so that we don't have to go through all the paragraphs again. So this is 3 meters per second. This point is 6 meters per second. The mass is 2 kg. I think the question is to find the acceleration of the block. Okay, so to find the acceleration of the block. So to find acceleration, what we need to find is the spring force. So we just need to find the spring force, because spring force is going to give me mass into acceleration. That's Newton's law, guys. The force acting on the block will give you mass into acceleration. There is no other force in the horizontal direction. Gravity is down, normal is up. No other force is providing that acceleration. So only one force giving that acceleration, as simple as that. So I need to find out Fs. But what exactly is Fs? Think about it. Spring force is nothing but magnitude wise k into x. Okay, that means I need to find k and x together. Thank you, Brem, so much. Hello, welcome, Crack with Gogulnath. Hello, Mansi. Hello. Thank you, Roshni, for asserting that. Hello, Tamil Rasu. Welcome aboard. Now, here is the challenging part. It is given that at this moment the potential energy is increasing at 15 joules per second. Why is the potential energy increasing? The answer to that is these two pieces of information. This point is moving at 3, that point is moving at 6. That means there is relative motion between the two ends of the spring. So if you sit on one end and look at the other end, you will see that point moving ahead. Can you guys guess what is the relative speed of end A with respect to the block? I'll just put up that information over here. What is the relative velocity of A with respect to the block? Look at that. A is moving at 6 and block is moving at 3. So what is the relative speed between them? Is it 6 plus 3 or is it 6 minus 3? Obviously it is 6 minus 3. Correct? Yes, very good Samir, very good Dakshin, very good RIC Milos. Yes, Roshni, that's correct too. So it's like two cars moving with the different speeds but in the same direction. So the faster speed minus the smaller speed. So that will be nothing but 6 minus 3, which is 3 meters per second. So for this point, this end A is moving apart. That means the spring is stretching. If the spring stretches, the energy in it builds up, and the energy is building up at 15 joules per second. That's what the question says. So how to do that? Well, that's not crazy. I'll tell you what you should do. The potential energy formula is half k x square. This is rate of change of energy. What did I tell you about derivatives? Whenever you see the word rate, slope, instantaneous or something like, differentiation, that means it is d by dx. So here it is rate of change of u, that means it is du by dx, derivative of this guy. Half and k are constants. So you have to take the derivative of just x square but with respect to time. Oops, sorry, I put dx over here, my bad. This was supposed to be with respect to time because it is joules per second. Now this du by dt is given to be 15. This du by dt, this is 15 joules per second, rate of change of potential energy. Well, this will be half into k. Now here is the catch. You cannot differentiate x square, guys, with respect to time. You can differentiate x square with respect to x, but not with respect to time. So you have to use the chain rule. Okay, so you have to, you have to use the chain rule. So this is actually speaking derivative of x square with respect to x into dx by dt. Why did I do this? Because when I multiply and divide with dx, what happens is one of the term gets dx square by dx. That means I can differentiate it. And the other term, dx by dt, is a very familiar term to you guys. What is this dx by dt? Think about it. It's nothing but velocity. Isn't that right? Dx by dt, rate of change of position, is velocity. So now it becomes simple. And what is this guy over here? This guy, derivative of x square. Well, we all know it is nothing but 2x. So in the next step, I'm just going to put this as 2x into v. Well, with that, this 2 and this 2 gets cancelled, and this v, be careful about it, is the rate at which this x changes. X is the extension. That rate will be this 3 meters per second. Yep, this v will actually be 3 meters per second because it's the rate at which the extension changes, the separation between them changes. So this is basically the rate of change of x. What is x? The extension, basically. The rate of change of extension. So how fast the extension changes will depend on, if you sit on one guy and look at the other guy, how fast is that other guy moving? How fast is the other end moving? So that's why you need to make use of 3. Is that clear? Everyone, think about it. That's the catch over here. Many people forget or put some value like 6 over here, thinking that dx by dt is 6. No, dx by dt is not 6, it is 3. It's the relative rate of change of, that extension. Okay, so instead of v, I'm just going to put this v as, what is it? 3 over here. So therefore, I'm just going to get kx is equal to 5. K into x is nothing but 15 by 3, which is 5. Now I can use this value of kx over here. Okay, I can use this value of kx over here, and see guys, what do you get? Kx is nothing but 5, mass is nothing but 2 into acceleration. Therefore, acceleration is 2.5 meters per second square. That is our final answer. What a brilliant question. Yep. So this is how you're supposed to solve and interpret physics. See guys, mathematics is a language. Mathematics just tells you, okay, this is the value of x that you're putting, this is the final output. It does not understand physics. You have to think, what is the meaning of dx by dt? You have to understand, oh, 15 joules per second, that means it is rate of change of u with respect to time. Okay, I cannot differentiate x with respect to time, that's why I need to use chain rule. Okay, dx by dt, that x stands over here for extension, so that extension depends on the relative speed. Alright, and once I get kx, I can just substitute. So it's just, nothing but getting those equations and substituting it here and there till you get your final answer. Making those equations requires good understanding, good conceptual knowledge, and obviously love for the subject. Well, I hope you guys have understood this question. Moving on to the next one coming up on your screen. Yeah, that was 2.5 meters per second square, like you can see. Oh, Zayed, welcome. And yes, guys, it's Zayed's birthday, so please wish him happy birthday. He will feel very happy about it. Yep, that's his day today. All right, cool. So let's get moving. So Krutika, if you join pro subscription today and for 2 years, I think the cost is somewhere around 50,000 roughly for the light version, and for the classic version around 65 or 63,000. So with the coupon code, so you will get the 10% off. If you want, you can even pay via EMI, so you don't have to pay everything upfront. You get all the features even if you pay via EMI. That option is also there. All right, cool. So moving on to the next one. There is a block. Oh, this is a JEE 2019 question. There is a block of mass m, and it lies on a smooth horizontal surface like you can see over here. And what is happening is that the other end of the spring, that is on the left side, is fixed as shown in the figure. The block is initially at rest. Interesting. Now the block, you can see it's pulled by a constant force F from the right side. And the question is, what is the maximum speed of this block? Interesting. Let's try and solve this question. Okay, so I don't need these options. I'm just going to get rid of them, and let's start solving this. Now let's understand what is happening. First, when this body started moving, there was no extension. The spring was completely relaxed. Okay, the other end of the spring is fixed as shown in the figure. The block is initially at rest and its equilibrium position. So its equilibrium, that means x is equal to 0. So at this point, x is equal to 0. But I think there is only one force. The spring force is, obviously, I'll just put over here. The spring force will be 0 because x is 0. There is no extension. So obviously there will be some acceleration over here in this situation. Once there is acceleration, obviously the velocity will increase. Now when the velocity increases and this block moves ahead, think what happens. As this block moves ahead, there will be a spring force over here, but this force F remains constant. As this block moves more ahead, the spring force increases. So there might come a point when this spring force will exceed the force from the right side. When that happens, don't you see that it will actually accelerate towards the left side and not towards the right side? Think about it, guys. I'm repeating. First, there was no spring force, only this force. As this block moves ahead, spring force starts to act. As the block moves more towards the right, the spring force keeps on increasing. There comes a point when they are equal, and if it proceeds more ahead, you will see the spring force will exceed, and that means the net force will be towards your left side. That means the acceleration will be towards your left side. That means it will decelerate, eventually it will stop and come back. See if it makes sense. Now the question says, find the maximum speed of the block. If you roughly or vaguely think about how the velocity is going to change with respect to time, what's going to happen is that the velocity will increase, reach maximum, decrease, and it will stop over here. It will stop over here. This is t is equal to 0. It will stop. Why does it stop? Because the spring gets extended too much, it will start pulling it. It will be very difficult to pull it beyond a point. So that's why it will stop. So there comes a point when the velocity over here, you can see, is nothing but, what is this? This is maximum. And when the velocity is maximum, there is a very interesting thing happening. If you draw a tangent, what is the slope? What is the slope, guys? The slope is 0, and acceleration of velocity time is, slope of velocity time is nothing but acceleration. So this slope is nothing but the acceleration of the body. So when the velocity is maximum, the acceleration is 0. Did you guys get it? What an interesting question. So acceleration is 0, that means net force is 0. Okay, that means the net force on that body will be 0 because acceleration is 0. Now what are the two forces acting on the body? Well, one is the force from the right and the other is the force of the spring. Therefore, the force from the right and the force of the spring should be equal. This is the force from the right, this is the force of the spring. Both will be equal and opposite, they will cancel when the velocity is maximum. Therefore, Kx is equal to external force. So, x is equal to F by K. So, what is this x? At this extension, at x equal to F by K, you know, the velocity is maximum. That's what I got. This is the x for which the velocity is maximum. Well, but the question is something else. Oh, the question is, what is the maximum speed? Now let's see, what do we do? The question is, what is the maximum speed? Guys, do you think we can use kinematic equations? Guys, do you think we can use kinematic equations? Well, I doubt it. We'll be like, sir, the force is constant. But think about it, the spring force is not constant. That means variable acceleration. That means kinematic equations are invalid. So that means integration, but I'm not so fond of integration. If I can avoid it, I will try and avoid it. Is there some way to avoid it? Well, maybe work. Yes, maybe that's why we are labeling this session today as work, kinetic, work, power and energy. So how about using work kinetic energy theorem, and maybe it will simplify things. Let's just try it out. I don't know. Okay, so what is work kinetic energy theorem? So work kinetic energy theorem says that work done by all the forces results in the change in the kinetic energy. So work done by normal plus work done by gravity plus work done by external force plus work done by spring force is equal to final kinetic minus initial kinetic. Now work done by normal, that's very obvious. Normal force is on the top, displacement is towards your right. Angle between force and displacement is 90, work done is 0. Simple. Okay. Gravity. Now gravity is acting down, displacement is towards your right. Again the angle between them is 90, so F dot S is 0, so 0 work done over there as well. Straight enough? Yeah? Very good. Now, thank you Vishal for filling it up. It means a lot because our team behind will definitely go through all the forms that you guys are filling in the description box below, so that it will help us improve and give you appropriate content. Now, what this means is basically, once you move ahead by certain x, okay, your force is here, the spring force is here. At this point, your velocity is in fact maximum. What is the work done by F? This force F, how much work did it do? Force and displacement, same direction, positive. So therefore I'll put plus symbol. Next thing, force is constant, x is the displacement. Obviously the work done will be F into x, straightforward. Force into displacement is work done. Now next thing, work done by the spring. Spring force is left side, displacement of the block right side. So you can see opposite, force and displacement are opposite, so negative work. So I'll put a minus sign. And what is the work done by spring force? The magnitude of it is just half k x square. So just put half k x square. That's it. So the sign should be decided by the directions. Magnitude is always half k x square. Now, what is the final kinetic energy? It is just half m v max square minus, what is the initial? Initial velocity was 0. Now this is simple, guys. Just substitute the value of x from here. So x is nothing but f by k minus half k x square. That means f square by k square is equal to half m v max square. So f square by k, one of the k gets cancelled. Again f square by 2k, f square by k minus half f square by k, that's nothing but half m vm square. 1 minus half is half, so half and half will also go, so I'll just get f square by k, okay, is equal to, if you want I'll just put that half and later on I'll cancel it so that you know what we have done. So this is vm square. Now therefore vm square is equal to f square by mk. Therefore vm is equal to f by root of mk. That is our final answer. Done. Yep, from here we got this. Got it, guys? What a brilliant question. Hello Anil Kumar, welcome aboard. Did you guys understand it? So the two concepts over here are, number one, understanding when the velocity will be maximum. So the velocity is maximum when it accelerates and then starts to decelerate. So just when the acceleration becomes 0, you can see it graphically, that's when the velocity is maximum. And we figured out that when acceleration is 0, by Newton's law, net force should be 0. That means spring force and the external force should cancel. The next point was using work kinetic energy theorem, because it makes us solve the problem in a very simple manner. It avoids integration. Remember, integration should always be avoided as far as possible. So, work done by that external force and the spring force, if you just take it into account, you get the answer. That's it. Yep, Sai Pujit, obviously this is advanced. Yep. Okay. So, moving on to the next question, D option, f by root mk. Here is the next question. Brilliant question coming up on your screen, guys. Okay. Samir Akhtar, if you use conservation of mechanical energy, that is wrong, Samir. Maybe you got the answer by committing some mistake. Remember, the mechanical energy was not conserved in the previous question. Reason, that external force F was acting on it. So, mechanical energy is conserved only when non-conservative forces are absent or they are not doing work. We do not know the nature of that force which is acting on it. Well, you can argue that it is a conservative force because it is constant force and all of that. But by that logic, yes, you can do it. But otherwise, I would prefer using, work kinetic energy theorem, because then it makes the problem simple. There is no ambiguity and there is no, doubt whether mechanical energy is conserved or not conserved. So I always prefer work kinetic energy theorem when in doubt, rather than mechanical energy conservation when there are especially some weird kind of forces in the system. Okay, moving on to the next one. In an industrial gun, a trigger is pulled and under the pressure, the barrel behind a ball of mass m, it slides smoothly in the barrel and it exerts some force which is given by this equation. L is the length of the tube and x is the instantaneous displacement. Like you can see, find the speed with which the ball comes out. Guys, have you ever seen or heard about paintball? Well, paintball exactly is nothing but, you have those small pellets. Exactly this kind of gun is used. There is gas filled, and what happens is, when you pull the trigger, that gas suddenly gushes inside. It pushes this ball, and that high pressure of the gas pushes that pellet outside, and when it strikes your body, that ball has a paint in it. So when it strikes your body, basically, that paint splashes. So if the paint splashes, that means somebody has shot you. So that's a fun way of playing this PUBG or all these games that you play, the first person shooting kind of games. So that's what it is all about. Great. Hello Kailash. Now that concept has been used over here. To cut the big story short, you don't have to worry about this entire thing. This is just there to confuse you. This can just come like a paragraph question in your JEE Advanced as well. The idea behind this question is to figure out the speed of the ball. Think of it this way. There was some force acting on the ball. Alright, there was a force acting on the ball. This was a variable force. Because of this force, it will accelerate, but this acceleration was definitely not constant. Eventually, from rest, that is when the initial kinetic energy was 0, it has achieved some velocity. That means there is some final kinetic energy. So can I not again use work kinetic energy theorem? Can I not just use, same type, but a different way in which it has been framed so that you get confused? It's all about using work kinetic energy theorem. So it's a very important theorem which you should know about this chapter. So the work done by that force is the final kinetic energy minus initial kinetic energy. Now that force is variable. That means here you will need integration. So that's the difference from previous to this question. This is a function of x. So integral of f naught into 1 minus x by L dx from 0 to L. Why 0 to L? Because the ball starts when the value of x is 0 and the final speed is when the value of x is the length of the tube. So from 0 to L, that's the limit, is equal to final energy, which is half mv square minus 0 because it starts from rest. Let's integrate, but before that let's split this term so that it looks very simple. F naught integral 1 into dx is just dx from 0 to L minus again f naught by L. Here I will have x dx inside the integration again from 0 to L is equal to half mv square. Now let's just integrate this. So this will become f naught. Integral of dx is just x, okay, from 0 to L, and this is nothing but f naught by L. X dx integral is nothing but x square by 2, again 0 to L. This is half mv square. Therefore, when you integrate and substitute the limits, first substitute L, then substitute 0, it will just become f naught into L, and this will become f naught by L, and this will become just L square by 2 is equal to half mv square. Now the next step, well, this L and this L gets cancelled, f naught L by 2 and f naught L. So f naught L minus f naught L by 2 is just f naught L by 2. So therefore this will just become f naught L by 2 is equal to half mv square. Therefore 2 goes, okay, so what was asked? V, right? So v square will be f naught L by m. So v will be root of f naught L by m. That's the final answer. Done, done. Very good, Swarlina. Excellent, Izad. Yes, correct, Ankit. Work kinetic energy theorem. Beautiful. Amazing. Go. Yep. So that's all. So this is the concept behind this kind of gun. So maybe someday when you go to a nice camp or maybe some nice resort which has this paintball, you will remember this problem, and when you probably sometime in the future play this game, you will remember the physics behind this particular gun. So it's a beautiful game. You can play it sometime and let me know the day you play this. Probably you can come back and comment on this video. Alright, that's the answer. Beautiful. Moving on to the next question, but before that, if you guys have any doubt, if you are 11th standard or 12th standard kids, please download our Vedantu app. There is a feature where you can ask doubts. You can not just take a picture but also chat with our doubt experts. You can even ask hints, and there is no limitation on the number of doubts you ask. From morning till night, on all the days, you can ask any question that you get stuck in from any book, from any chapter, so that you don't have to ask your friends or randomly search on Google and not know whether that is correct or wrong, because many times even the Google results give you or lead you to some websites which might lead you to some wrong answers. Okay, and remember guys, the entire PDF is available to download in our Telegram channel. There is a link in the description box. Download it. So today's session is available on our Telegram channel as well. Okay, chalo, let's move on to the next question. A particle of certain mass, 1 kg, is free to move along the x-axis under the influence of some conservative force, and there is some potential energy, a x raised to 4 by b minus 5 x raised to 2 by b. Okay, some crazy function, joules. B is 1, A is also 1. What nonsense. I mean, like, really, A is also 1, B is also 1. Adobe, you don't have to pay anything for the doubt app. If you are a part of the pro subscription, it is for free. If you are in the classic or in the plus version, that feature is for free. Yep. Okay. So yes, Russell, you should definitely, but after completing the syllabus, after 12th, not before that. Find the coordinates where we can expect to find the particle and what is the type of equilibrium. Okay, so first of all, let's get rid of these numbers and make it look simple so that you guys don't get scared by it. A is 1, B is also 1. Beautiful. So therefore, U is nothing but x raised to 4 minus 5x square. This is the function. Now it looks so simple and neat. Now you feel little bit confident that okay, maybe I can just solve the problem. The question says the total mechanical energy is 0. Achha. Guys, remember one thing. If you have energy graph versus position, that is x. Well, let's say this is my potential energy graph. This is U. Okay, potential energy graph, U as a function of x, some random graph. If I tell you my total energy, okay, is some value, okay, this is my total energy. The interesting thing is, remember, since total energy is the sum of potential energy plus kinetic energy, potential plus kinetic, the sum should be constant. That means if the total energy is that green line, think what is so special about these 2 points over here. What is so special about these 2 points over here? At these 2 points, the potential energy is equal to the total energy. That's right. The potential energy is equal to the total energy. At some other point, what happens is, if let's say I take this point, this much is potential energy, then the remaining part is the kinetic energy. Potential plus kinetic is total. So at this point, the entire thing is potential. So that means what is the kinetic energy? It is 0 and it is 0. So it also tells me one thing, that I cannot go beyond this point. Yes, obviously I cannot go beyond this point, because how can my potential energy be more than the total energy? Do you guys agree with this? Think, if I go beyond this point, potential energy will be more than total energy. That means kinetic energy will be negative, and kinetic energy can never ever be negative. That makes sense, right? So you can never have negative kinetic energy. That means you cannot exceed beyond these 2 points. That means in the question, find the coordinates where we can expect the particle to find. So where all can the particle exist? The particle can exist only in this region. Only in this region it can exist. Yep, exactly, it can exist in this region, because beyond this point it is not allowed to exist. Yep. Now comes the next concept. Okay, fair enough. So I will write this. My total energy, my total mechanical energy is equal to potential energy plus kinetic energy. And we know that this sum cannot exceed this. That means what I'm trying to say over here, this sum should always be less than or at, equal to this particular mechanical energy. You can never ever go beyond this. That means your potential energy function should always be less than the mechanical energy, no matter where you go. You can see potential energy is always less than the total energy. That's where you can exist. So this is where it exists. You can see that. This is where it exists, wherever potential energy is less than the total energy. Okay, now this is simple. The total energy is already given to me. What is the total energy? Total energy is 0. Okay, so 0 is more than equal to, just write that equation. What is that equation? It is x raised to 4 minus 5x square. Okay, so therefore 0 is more than equal to, okay, x square is common and x square minus 5. Now, when you talk about x square, guys, x square is always a positive number. So don't even think about it. So forget x square. Just forget x square. So you are talking about all those numbers which are, lesser than 0. So that means you are talking about 0 more than x square minus 5. This is inequalities. So therefore, what are you getting? Take 5 on that side. So 5 more than or equal to x square. Therefore, x is less than, mod x, I would say, is less than root of 5. Because when you take root x square, okay, so remember you have to put modulus symbol. Now, the square of x, understand, should be less than 5. That means x, the value of x should be less than root 5. But that's the modulus of it. So actually speaking, the value of x can be anywhere between minus root 5 and also plus root 5. Understand that. So anywhere between that. I hope this makes sense. I hope this makes sense. Think about it, because this value, be it positive or negative, the square of it will always be positive. So the square of some number should be less than 5. That means that number should be between the negative and the positive more extremes. Yeah, both the extremes. I hope this is clear. That's the logic behind it. Hence, I have found out the place where it exists. So the value of x should be less than root 5, and it should be probably, I don't need this anymore. Okay, it should be more than minus root 5. So that's what I got. This is the value of u. Fair enough. Now, going to the next part. Okay, so I don't need this anymore. I'll just get rid of this. Okay, this is not needed. Now, the question is also find the equilibrium. Okay, I think I know what to do. If you recollect very carefully, I had just talked about equilibrium in my previous classes, and you have stable, unstable equilibrium. This was unstable. Unstable happens at maxima, if you remember, and this was stable equilibrium, and it happens at minimas. So the first step for you guys will be to differentiate this function. Okay, let's just differentiate this function and see what do you get. So du by dx will be x raised to 3, and this is 4, and you will get 10x. That's what you will get. That's the first derivative. And the second derivative, d square u by dx square. 4 3s are 12. So 12x square minus 10. Okay, these are the two derivatives I will need for maxima minima. Remember, at minima or maxima, du by dx is 0. So we know that. At minima or maxima, du by dx is 0. Therefore, 4x cube minus 10x is equal to 0. Now just move this around. Okay, so we have got x into, well, 4x square minus 10 is equal to 0. So I have got two solutions, x is equal to 0 or x square is equal to 10 by 4. So 4x square minus 10 is 0. That means x square is 10 by 4. That is, x is plus or minus 10 by 4 is 5 by 2 plus or minus root 5 by 2. So x is 0 or x is plus or minus root 5 by 2. At all these points, you will see the slope is 0, but I do not know which one is maxima, which one is minima. So what do I do? Then use the next concept, second derivative. At maxima, the second derivative is negative, and at minima, the second derivative is positive. Remember, I have given you this rule, and that's the basics of maxima minima. Okay, so just substitute x equals to 0 and see what happens. So for x equals to 0, d square u by dx square will be, just substitute x as 0. So 12 into 0 square minus 10. So that's going to be minus 10, which is negative. That negative means maxima, and maxima immediately means what? Unstable equilibrium. So at x equals to 0, you have unstable equilibrium. That's the first thing that we got. Great. Now substitute x is plus or minus root 5 by 2. You will get d square u by dx square is equal to 12 into square of root 5 by 2. Whether it is positive or negative will always be 5 by 2 minus 10. So this will become 6, 6 5 are 30, 30 minus 10, that's 20, which is positive. Now positive means it is a minima. So it is a minima, and if it is a minima, that also means it is stable equilibrium. So for this value, you will see that it is going to be a stable equilibrium. Now if you guys do not believe me, I will show you a graph, and that will be crazy. Okay, do you guys want to see a graph? How about showing you guys a graph? Okay, let's see this. Okay, just remember this, at x equals to 2 values, root of 5 by 2 and minus of root of 5 by 2, you get stable, and at x equals to 0, you get unstable, which is a maxima. Just keep this in mind. I'll show you all of this so that you get a hang of it. Okay, probably I should have the graph over here. This is on Desmos. Okay, I have already plotted that function. X raised to 4 minus 5x square is y. Okay, so this is my graphing calculator Desmos, and let's see how this graph looks like, and that's it. Look at this, guys. This is such a beautiful graph. At x equals to 0, look at this, 0, you get unstable equilibrium, that's maxima. And at minus 5 by root 2 and at plus 5 by root 2, you get the two minimas which are stable equilibrium. So if the particle is trapped here, it will just keep on oscillating. It will be at stable equilibrium. If you move it here, it will come back. If you move it here, it will come back. If you move it here, it will come back. If you move it here, it will come back. And over here, it's at equilibrium, but if you move it slightly here, it will fall. If you move it slightly here, it will fall. So that's unstable equilibrium. That's how it is. Yes, Zoheb, there is one. In fact, I have shared the link of my personal channel, the Telegram channel, as well as my Instagram account is also there. And my personal Telegram channel, it's already shared on our official Telegram channel just few days back. If you have joined our official Telegram channel, you will be able to see it. Okay, beautiful question. Very good. So that's the answer. Shall we go ahead to the next question, guys? Are you guys now ready? Okay. Trusty, bacha, let me tell you. Number one, if you're in 11th, I do not, really expect you to think at this level maybe so fast. I'm just telling you this is how you should think eventually. You should know where you should be. You should not be in the dark. Many channels or many coaching institutes don't even discuss these kind of questions. That's the problem, bacha. So what happens is when you actually see the exam paper or when you see the test, you guys get very scared and you guys feel that what is wrong? Because you are never exposed to those kind of questions. Understand? Only when you are exposed to these kind of questions will you start thinking. If you do not know only what is, it's like telling a blind person, what is green color or what is red color. So if you have not, or maybe if you have never seen, let's say, imagine if you have never seen an aeroplane, okay, there is no point of somebody talking about an aeroplane. If you see an aeroplane, then you know, okay, what we are talking about. And first time maybe when you see an aeroplane, you might be like, wow, so cool, such a big thing, how does it fly and all of that. But once you start seeing aeroplanes daily, you're like, okay, big deal. It's a normal thing, it's a casual thing. So that's what I want you guys to get used to, bacha. Right? That's what is important. Don't worry, don't get scared, Srashti. We are there with you, I'm there with you here. And please take it up like a motivation, please take it up like a challenge that yes, I'm going to solve more questions like this, and no matter what comes, I'm not going to give up. Don't worry, bacha. Okay, moving on to the next question. Beautiful question. This is from I Irodo. Honestly, I was thinking 10 times whether I should put this question or not, but I thought, let's give it a try. I hope you guys are up for the challenge, okay? You should not get scared by this name. Russians are really scary, but it's okay. A body of mass m is slowly moved up, I don't know why this word, it slowly moved up the hill by a force F, which at every point was directed along the tangent. So you can see the body goes like this every time the force is along the tangent. Okay. Show that the work performed by this force, if the height of the hill is h, the length of the base is L, and the coefficient of friction is mu, is independent of the shape of the hill. Very interesting, and we have to also find out the work. What this means is that even if the hill was shaped like this, but if you reach here, okay, this work comes out to be independent of how the shape of that hill is. Be it like this, be it like this, it really doesn't matter. Okay, interesting. Let's try to first of all think about what are the forces acting on it, and maybe I'll get some idea. Okay, one thing is that there is going to be a normal force like this, and mg will have two components. Okay, so okay, let's do one thing. Let me just draw those perpendiculars. I think I had drawn those perpendiculars on my slides. Okay, yeah, there we go. Okay, these are the perpendiculars that I will draw. This one is the tangent, this one is along the perpendicular to the surface. Okay, so normal obviously has to be along that perpendicular. It is going to be like this. There will be mg components over here. There will be one component like this, and there will be one component like this. Now if I assume that this angle is theta, this theta will keep changing. It's a variable, it's not constant, be careful. So we know this by simple logic, that this will be 90 minus theta, and this will be obviously again theta. So that means if mg acts downwards, so there are two components, one will be mg cos theta, and the other one over here will be mg sine of theta. There is only one force remaining, and that is friction, and this friction will be mu n, but n is mg cos. Look at that, n and mg cos are same, so this will be nothing but mu mg cos theta. So that's the value of the frictional force. I think till this point everybody is clear. Very good, great. Yep, Gautam, if you start your JEE preparation from now on, you can still get a good rank in JEE mains, nahi, even JEE advanced. Guys, don't aim lower, always aim higher. You can definitely get very good rank. Yes, in EWS 14K you can get into NIT. Hello Kavita, thank you so much. Yes, you can get bacha. Okay, yep. Now here is the thing, the displacement is happening like this. This is, let's say, ds. For example, s is the displacement, ds is a small displacement. Why am I taking ds? Every time it moves, the angle changes, the displacement is in weird directions. That's why I'm taking that. Okay, now it is moved slowly. This is the most important word, slowly. Slowly means velocity is negligible. Now use work kinetic energy theorem. It helps us every time. Work done by that force plus work done by gravity plus work done by friction is equal to final minus initial kinetic energy. Use work kinetic energy theorem. Oh, I missed the work done by normal. Yep, work done by normal as well. Now the best part is normal will not do work. Reason, it's perpendicular to the displacement, as simple as that. Okay, so normal has not done any work, or it will not do any work. Work done by that force, well, that force and the displacement both are in the same direction. That means work done should be positive. So it should be F into ds. Straightforward. Next, gravity. Now gravity has two components. Out of that, mg cos is perpendicular. that will not do work. Remember, perpendicular forces cos theta, cos 90 will be 0. Only this negative force will do work. Acha. Why negative? Because it's opposite to the displacement, so negative work. Okay, so that work is negative. So minus mg, what is it? Sine theta into ds. Interesting. Great. Work done by friction. Oh, friction is also opposite to the displacement. So again negative work. So minus the frictional force, minus mu mg cos theta into ds. Okay. Now the question is, how much is this work? Oops, we have to actually find out this work, guys. We are supposed to find out this work, so let's not substitute this. Let's just call this as the small work done by that force, because the displacements are also small. This is very important. Why am I using this dw? Because the displacements are very small. Okay. Now final and initial 0, 0, because velocity is negligible. Get rid of it. From this I'll get the work done by that force externally, because that's what is asked. How much is this work? Move these two guys over there. So you are going to get mg ds sine theta plus mu mg ds cos theta. This is the step where you should take a pause, because after this I'm going to integrate. Mg is a constant, integrate. Mu mg is a constant, integrate. This integration dw work done for small displacements will give me the total work done. That means it should be work done by that force F. This will be mg. You'll be like, sir, what is the value of this? You don't even have to integrate. Trust me on that. You don't have to integrate. I'll tell you why. Look at this diagram carefully. ds is that small displacement, right? ds was that displacement. Now let me just draw a triangle like this. This is theta. Guys, this base is nothing but ds cos theta, and this height is nothing but ds sine theta. Does that make sense to you? This ds is split into two components, ds cos theta, ds sine theta. What is this ds cos theta actually? This is displacement in the x direction. Correct? Displacement in the x direction. And ds sine theta, this is the displacement in the y direction. Isn't it? Got it? Now what I will do, I'll just put this as just integral. Instead of ds sine, I'll just put integral dy, and I'll just put over here, instead of ds cos, I'll just put integral dx. Now you'll be like, sir, what is the advantage of that? Guys, integral dy. dy is the small y displacement. If you add all those y displacements, what will you get? You will get the total height. Integration is just addition. Yep, I hope this is clear. I hope this is clear. What is integral dy? dy means small displacement in y. If you keep adding dy, what are you going to guys get? You're going to get just the height h. So this will be nothing but mgh plus mu mg dx. dx is the small displacement in x. Keep adding those small displacements. What is my total displacement in x? It is just L. So mu mg L. So therefore the final answer is mg h plus mu L. That's it. That's the work done by that force, and nowhere does the path come in play. So it's independent. That's it. What a brilliant question. Did you guys love it? So it is independent of what is the shape, because the shape never mattered the way it is. Brilliant, amazing question, guys. Moving on to the next one coming up on your screen as the answer. Okay, this is a oops, this answer was not supposed to be shown. Okay, well, hello Harsat Bhinav, welcome aboard. Welcome. Now let's solve this question, guys. Okay, and here it is. So you have a block of mass m and it is attached to a massless spring of force constant k. Okay, and the question is basically the block is placed over a rough inclined surface and the coefficient of friction is 3/4. And the question is, what is the minimum value of that capital M required to move the block up the plane? So what is happening is, you take some mass, you leave it, this mass will go down, this spring will stretch, this block is at rest because of friction. Now if you put a small mass, it will go like this, stop, and it will go up. It will keep oscillating up and down. Even if it is oscillating and even if it is stretching till this much amount, the spring also stretches like this. Okay, the spring stretches, the pulley moves, and the block goes up and down. But the spring extension is not enough to create a force to pull this block up. So if you have a small mass, this mass will go down, it will come up, and it will keep on moving up and down. The spring will keep on stretching like this. The stretching is not enough to pull this block up the plane because it is probably not helping it against, that friction and all of that. So what do you need to do? Well, Zayada already putting up something. Okay, so guys, since I have already posted the answer, because by mistake I showed you the answer, I'll just give the hint of solving this question and I'll leave it up to you to get to the final answer. Okay, so I'm just going to give you some hints. So you're going to solve it and then put up a yo, yes sir, I was able to solve it and I got the answer in the comment section after the video ends. So look at it. First of all, when you have that mass, critical mass over here, which is just enough to move this block, that means, think about it, the spring force is just enough to balance your mg's component. There will be two components over here. There will be mg cos 37 and obviously mg sin 37 degrees. And there will be also friction over here. There will be normal over here. This normal will be equal to mg cos 37. And this friction, which is mu n, that will be mu mg cos 37. When this is about to slide, think about it. The spring force will be just equal to mg sin 37 plus this frictional force, which is mu mg cos 37. Do you guys agree with it? The spring force is just enough to balance these two forces, and if the spring force exceeds anything beyond this, you will see it will overpower these two forces and the block will move up. So this is the minimum spring force which is needed to move that block up. Everybody agrees with this? Everybody agrees with this? Mrutyunjay, you can watch the replay later on. Okay? Yep. Now, the next part of this problem, by the way, you will be like, sir, what is the spring force? Spring force is nothing but kx. Well, this is one part. The second part is, when will the extension be maximum? When will the spring force be maximum? The spring force, I'll just put it over here. The spring force will be maximum when this extension is basically maximum. And when will this extension be maximum? When this block has come to the maximum displacement below. So that means this mass has moved as much as possible below. So this is the max displacement. It has moved by some x amount. So whatever spring extended, that much amount the mass has come down. So after this, it is not able to move. Okay, this mass was left, it moved, it stopped, and it is going up. Before that, because it has moved by the maximum amount, the spring force is maximum. It is enough to overcome the friction and the gravity. So at this position, don't you agree the velocity will be zero because it just stops. This is that limited critical mass. Anything more, it will not stop. Think about it. Think about it. This mass is the least mass to move it. If you put more mass, before it stops, it will start going down. This block will move up because the spring force is much more than what it is needed. So when that mass is just the minimum limited critical mass, you will see the mass will just stop and it is just enough to pull this block up. So I think you should use work kinetic energy theorem, guys. So work done by the spring over here plus the work done by gravity will be final minus initial kinetic energy. Can you guys guess what's the final kinetic energy? Because it just stops over here, obviously it is 0, and it just starts from here, that means the initial kinetic energy is also 0. Now you solve this and you're going to get the answer. Understood? Clear? What has happened? It started from rest, accelerated, stopped. Spring force is maximum and it is going to go up, but even before that, the spring force, which is maximum, is just enough to pull this. That's all. Just use this, now you'll be able to get it. I think I showed you the answer before, but you can try it out later on and try to get this. So guys, if you are loving these kind of questions and you want to check out my micro courses, you can see that for 11th standard, I have HC Verma micro course, I have problem solving micro course, I have Aerodove micro course and derivation micro course for all of you. Not just my micro courses, thousands of micro courses, KVPY batch, the long-term crash course is also there. So that even if you have decided late to start preparing for JEE, there is a batch which has just started. You can get yourself enrolled into that, and that too it is in English, and that's the best part, that you are going to get good quality teachers, so you don't have to run around anywhere sitting at home, because you know it's the pandemic era and times are very uncertain. We do not know when coaching institutes shut down or when they open, and they charge you fees for offline, but they give you online material. That's not fair. So we do not charge you offline fees. So our fees are much less than the ones that you can probably see around your neighborhood. So what you get is your live classes, test series, analysis, standard PT, parent teacher sessions, guidance sessions, strategy sessions, revision sessions, and these courses are for 2 years, and the 2 years price is much lesser than even your installment or probably 1 year fees for your regular coaching. Yeah, that's right. You get doubt solving, personal mentorship under plus and classic packages. Most of the students go for the classic version. Some students also go for the plus version because they want that personal mentorship where you have a personal mentor helping you out with your doubts and queries and guiding you through how you should study. So the course price is as low as 3,600 rupees per month, and you get 10% off if you join using the link which is there in the description box below. So if you're already watching this video right now, so all you have to do is probably go to the description box down over here, and you will see there is a CBSE batch starting, there is a 11th and 12th science batch, and you can see this is the pro subscription for JEE. So you can see everything is offered, including revision, notes, booklets, everything. Whatever I just showed you, it's out here. You can try it out for 1 month for 2,700, or you can buy the complete course, and that's when you will get better deals, and the total cost works out really well. So you save 10% on that. So everything that you need is over there. Just check out the link which is there in the description box below. Okay, thank you guys very much for joining in. Do not forget to like and also hit the subscribe button if you are new to this channel. Bye bye Ishpreet, bye bye Arvind, take care. Revansh, hello Dilip, you can watch the recorded part. Thank you Srashti. I want to learn CBSE, but I can also practice Tattva JEE questions. Will it give me better results? Yes Mangalam, definitely it will give you, bacha. Okay, so Mrityunjaya, just watch this lecture in the last problem in replay. Trust me, you will understand it. Still, if you did not understand any particular part, leave a comment after the video ends. I'll definitely help you out with it. Okay, bacha? Take care, Mrityunjaya. Have a great time and study well and stay safe. See you next week for the 11th standard classes, but there will be also some special classes which I have planned for you guys in this particular week. Do attend that, and next week we are going to start off with circular motion. Okay, bye bye, take care, good night, hasta la vista.